Unit 9 practice test, we are going to start by looking at a soccer ball. I went ahead and wrote down the volume formula since the question asks us how much air is inside the soccer ball, so that is asking us to find the volume. We're going to round to the nearest whole number, and they're giving us the diameter of the soccer ball, but when we are finding the volume, we need the radius, and we find the radius by dividing the diameter by 2. So to get the radius will be 8 divided by 2, and we get 4. So I'm going to plug 4 into my volume of a sphere formula. Again, I wrote that already. Now we're just going to plug it in to the calculator. Okay, so I'm going to do this for the numerator. Then I'm going to hit divided by 3, and this gives us about 268 inches cubed when we round. For number 2, a cylinder and a pyramid are shown. We're going to complete the sentence with greater than, less than, or equal to, rounding to the nearest whole number. We're comparing the volumes of each of these solids. So I went ahead and wrote down the cylinder volume formula for this one, and then we have our pyramid, and I went ahead and wrote down that volume formula. So we're going to find the volume of each, and we're going to compare. So here we have the radius is 1 in the cylinder, and the height is 9. So when we plug that into our formula, looks like this, and in the calculator, when I type that, we end up with about 28.27 for the volume of the cylinder, but it said round to the nearest whole number. We can put 28. All right, for the volume of the pyramid, so we have our overall formula for the volume of the pyramid where capital B means the area of the base. So when we look at the base of the pyramid, we see that it's a rectangle. So if I want to find the area of the rectangle, it would be 4 times 2. So that will get me the area of the base. Then 6 right here is the height of my pyramid. So I am, you guys, in the formula, I totally made a mistake. We need to definitely always divide by 3. So once we multiply the area of the base with the height, we divide by 3. So I'm going to put that in my calculator. 4 times 8 times 6. I'm sorry, 4 times 2 times 6. And we are dividing that by 3. Always divide by 3 in the pyramid. Okay, so I got 16. So the volume of the cylinder we know is greater than the volume of the pyramid because 28 cubic inches is greater than 16 cubic inches. For number 3, we're going to figure out which three-dimensional geometric object is created by rotating the flag 300 degrees around the flagpole. So we can look at this and try to imagine if it were rotated, we would see that this flag would look like this. And that is going to create the three-dimensional cone. Number 4, we have a cylinder shown below with a horizontal axis and a vertical axis. What are the vertical and horizontal cross sections of the cylinder? So we're very specifically going to write down horizontal. The horizontal cross section would be if we were to slice this horizontally, we would see a circle. Okay, and looking down at the base kind of helps you with that. So we know that the horizontal cross section is a circle. And then for the vertical cross section, which is that line up and down, if we were to vertically divide this cylinder, you would see a square. Okay, so the cross section would be a square happening here. Or I'm sorry, not a square, a rectangle. Rectangle. We don't want to assume it's a square. Okay, so that would be your horizontal cross section and then vertical cross section of a cylinder. And number 5, we have an ice cream waffle cone that can be purchased, and they're giving us that the radius is 3 and the height is 15. They want to find the amount of ice cream in the cone, so that's why I went ahead and wrote down our volume of a cone formula. So I'm going to go ahead and plug in the radius for R and the height for H. Remember, finding the volume of a cone, we always divide by 3. So plugging in 3 for the radius, 15 for the height. Divide by 3. They want us to round to the nearest tenth. So putting this in my calculator, pi times r squared times the height. I'm going to press enter. And then the division symbol to divide by 3. And this gives us about 141.4 cubic centimeters for the amount of ice cream fitting in the cone. For number 6, we're finding the length of AC. I'm going to put an X there, and this is going to require the Pythagorean theorem. We use the Pythagorean theorem whenever we are given 2 out of 3 side lengths in a right triangle. So we know to always plug in the hypotenuse for C. So x squared plus 7 squared, those are the lengths of the legs for A and B, and this is equal to 9 squared. So then 7 squared is 49, 9 squared is 81. Subtracting 49 gives us that x squared is equal to 32. And then our last step to isolate x is square rooting to get the square root of 32. Okay, but we've talked about how to simplify here. When we're simplifying a radical, you think of our list of perfect squares like 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So from this list, you want to choose the largest number that can be divided out of 32. That would be 16. So we can rewrite 32 as 16 times 2. So square root of 16 times the square root of 2 would give us 4 square root 2 for the length of AC. Solving for x, I'm going to label with respect to the given angle. They want us to find the length of the hypotenuse given the adjacent side length. So if you remember our mnemonic device, SOHCAHTOA, adjacent and hypotenuse, we want to use the cosine function. So we write this as cosine 32 degrees equals adjacent over hypotenuse. Then I'm going to multiply both sides by x, and x times cosine 32 degrees is equal to 18, and our final step to isolate x is to divide cosine 32 to both sides of our equation. So 18 divided by cosine 32, we're going to type that in the calculator. And that's going to give us about 21.2. For the length of that hypotenuse, or for x. And number 8, we're looking at a 45, 45, 90 triangle where we have special rules that say the lengths of the legs are congruent, and the length of the hypotenuse is the leg length times square root 2. So if I know that the length of the leg is 3, then the hypotenuse is 3 times square root 2, or 3 square root 2. And number 9, we're going to write the equation of the line passing through the point parallel to y equals 3x plus 4. So if we want to write the equation of the line given a point and the slope, and I say that because if it's parallel, then we need to use the same slope as the line given. So we'll be using a slope of 3. This will require us to use our point slope formula, where we will be plugging in the ordered pair, -4, 2, for x sub 1 and y sub 1, and we will be plugging in the slope of 3 for slope m. Since in the formula it says minus y sub 1, that means opposite y sub 1. So if it's positive 2 in the ordered pair, we write minus 2. I'm plugging in the slope here is 3, and then in parentheses x, and then opposite x sub 1. So minus x sub 1 means here we're going to have plus 4. And then we distribute into parentheses. And lastly, isolate y, adding 2 to both sides. So our answer is y equals 3x plus 14. Number 10, we're going to find the length of GH given the endpoints. I'm going to label these endpoints as x sub 1, y sub 1, x sub 2, y sub 2 for one ordered pair and the second ordered pair. So following our length or distance formula, we need to find the difference in the x values. So -4 minus -1. Be very careful that we understand there's two negatives. We're going to square that. Plus the difference in y values, so -7 minus -1. Again, be very careful of the minus negative. We need to know that when you're subtracting a negative, it means we're adding. So -4 plus 1 gives us -3. And then again, same thing happens here. This is -7 plus 1. That's -6. So then when I square each of these numbers, -3 squared is 9, -6 squared is 36, and 9 plus 36 is 45. Again, when we have square root of 45, I want to simplify by thinking about the list of perfect squares like 2 times 2, 3 times 3, 4 times 4, 5 times 5, and that list goes on. So I'm able to rewrite 45 using a factor of 9. So we could rewrite this as 9 times 5, and the square root of 9 is 3. Can't take the square root or simplify 5 further, so 3 square root 5 would be the length. Number 11 is asking us to find the slope. So I went ahead and wrote down my slope formula. Then I'm going to label the ordered pairs, and the order that we're labeling really doesn't matter. So I'm going to be able to find the rise by subtracting the y values. So 4 minus 8 for the rise, and then for the run, subtracting the x values is -2 minus -3. 4 minus 8 is -4. Here, this double negative minus a negative becomes a positive, so -6 plus 3 is -3. We do not leave our answer like this. We know that a negative divided by a negative is positive 4/3 for my slope. Number 12, a cylinder has a height of 12 centimeters and a volume of 300 pi. We're going to use this information to find the radius of the cylinder. So the very first thing I'm going to do is I'm going to write down my formula for volume of a cylinder, since that's what the information is talking about here. So the volume of the cylinder, we have pi r squared times height, and I'm going to plug in all of the given information. So right here, we know the height is 12 centimeters. The volume is 300 pi. And they are asking us to find the radius. So leave r there. Don't plug anything in for r for radius because we are going to be solving for that. So with this equation, if we want to isolate r, we're going to need to divide away the pi that's multiplying, and we also need to divide the 12. So I'm going to rewrite that as 12 pi. So ultimately, we're dividing 12 pi to both sides of the equation. We did that because we wanted the pi to cancel out here and the 12 to cancel to leave us with r squared. Then 300 pi divided by 12 pi, the pi's cancel, and in our calculators, or using mental math, 300 divided by 12 is 25. And then we have a last step to solve for r. The inverse of squaring is to square root, so that will cancel out to leave us with r equals the square root of 25, and the square root of 25 is 5. So the radius of the cylinder is 5. Number 13 is a review from Unit 8 where we are looking at a circle with an inscribed angle. We are going to find the length of TV. So right here, using this inscribed angle, we need to remember that from the inscribed angle to this we call an intercepted arc, you multiply by 2. So the measure of TV, arc TV, is 60 degrees. 30 times 2 gave us 60. Then we're going to find the measure of VU. Arc VU is here. We're going to use the fact that this is the diameter. So we know that this arc VU plus 60 degrees equal half of the circle, which is 180 degrees. So then that means that that arc VU that I highlighted must be 120 degrees. 120 degrees. I'll make a note of that. And then lastly, we're going to find the measure of arc TUV. So remember, this is a major arc, meaning we're going to go half of the circle or more. So you go in the order of the letters T, pass through U, ending at V. We know that the entire circle is 360 degrees, and what I just highlighted is almost the whole circle, but we're leaving out 60 degrees. So 360 minus 60 will tell me that remaining arc measure, 300 degrees. For number 14, we're going to find the volume of each prism. So we have a rectangular prism and we have a triangular prism. Each of the prism formulas are read as the area of the base times the height. So if you look at the base here, you would just multiply 6 and 8 to find the area of the rectangle and then multiply by the height. So area of the base would be 6 times 8, since that's a rectangle, and then we would multiply by 15. So in the calculator, 6 times 8 times 15 gives us 720 cubic yards. And then I'm just going to show you another way to find the volume of a rectangular prism that's usually taught when you're a little younger, or maybe even this year. I like to show my students this one, length times width times height. That works for any rectangular or square prism. Okay, so you can just use this one where you just multiply length, width, and height, which is the same thing we did, 6 times 8 times 15, and you end up with 720 cubic yards. Okay, so either way. All right, for part B, since this is a prism, we follow the same formula, area of the base times the height. So in this prism, our base is a triangle. So if we want to find the area of the base, we need to remember how to find the area of a triangle, which is 1/2 base times height, or base times height divided by 2. So it's the base and height of the triangle multiplied by the height of the actual height of the prism here, which is that. Let me see, what number is that supposed to be? I hope a 9. Mine got a little blurry. Yeah, that's a 9. Okay, so 1/2 base times height in the triangle is going to be 12 times 5 divided by 2, and then times the height here of the prism times 9. So if we put all of that into the calculator, we have 12 times, or without a calculator, 12 times 5 is 60, 60 divided by 2 is 30, and then 30 times 9 is 270. So 270 cubic meters would be the volume of this prism. Another way you can think of this is how it relates to the rectangular prism. If you like using length times width times height, you can remember that a triangular prism can be thought of as a rectangular prism divided by 2, or half of a rectangular prism. So we could use this formula for the triangular prism if you want to memorize that, where It's length, width, and height, which we did already. Well, just in a different format. 5 times 12 times 9, but then you divide by 2. And then you end up with the same answer of 270 cubic meters. So either formula that you want to use would work. For number 15, we're looking at buying 2 different options for ice cream. So we're looking at 2 of these cones with the given diameter, and then this cylinder with the given diameter and height. So we're going to find the total volume of option 1. So what we see here is figuring out how much ice cream is inside. So we're finding the volume of a cone, which is why I wrote that formula. But since they're giving us the diameter is 4, remember to divide that by 2. So the radius is 2. 4 divided by 2 is 2. So to find the volume of one cone, we're going to use the formula pi times the radius squared times the height. And I'm going to put that into my calculator. You could leave it as exact volume, but I'm going to go ahead and put it all in the calculator as pi times radius squared times 12. This volume is about 150.79 or 0.8. I'll write 0.79. So this is the volume of only one cone. So if there are 2 cones, then we're going to take this number in the calculator. Let's just hit multiply by. We're going to multiply by 2. So for 2 cones, we're just going to say, oh, multiply this by 2, and we'll get the total volume of these cones together, which is about 302. So 302 centimeters cubed, or cubic centimeters. Okay, volume of one cone multiplied by 2. You guys, I did it again. I forgot to divide by 3. Let's back that up. That is my bad. My mistake. I cannot restart this video, so I appreciate your patience. Okay, so do not make that mistake on the test. You always divide by 3. So let me go back. I'm going to put this in here. 2 squared times height, okay? And then divide by 3, which I failed to do earlier. So the volume of one cone, we're going to say, is about 50.27. And then the volume of 2 cones we get by taking that number and multiplying it by 2. That will give us about 100.5. So I'm going to write down on here about 101 cubic centimeters. So that's the amount of ice cream in option 1. In option 2, we have our formula for the cylinder, which is pi r squared times height. And again, we are given diameter, but we need to know to divide that by 2 to get the radius. So here's our height. Now we know our radius, and we're plugging that in to the calculator. Pi times, pi times 2 squared times 8 is about 100.53. So it looks exactly the same as what we did up above. Okay, so 101. So we did that. We found the volume of option 1. We found the volume of option 2. Let's say about 101 cubic centimeters and about 101 cubic centimeters. So which option has the largest volume of ice cream? We will say they are the same. Okay, and then you can even see them in the calculator. They're exactly the same from what I got with the cones versus the cylinder. Okay, number 16, we're going to solve the equation using the zero product property That means the factoring method. So we are going to factor this trinomial, opening up two sets of parentheses. Once we factor our parentheses, factor the equation, we set each of our factors equal to 0. So we know 2x times x is 2x squared. And then numbers that multiply to give us 15 could be 5 times 3 or 3 times 5, 15 times 1 or 1 times 15. If we tried 5 and 3, that would be a good pick because multiplying the outside, 2x and 3, give us 6x. And then multiplying the inside, 5x. Our goal is to add up to this middle term right here, 11x. So both of these need to be positive. So we have a positive 6 that we get from multiplying 2x times 3. And then we need a positive 5 that we get from multiplying these middle terms. So now that I have each of my factors, I set them equal to 0. And then I'm solving each equation. So here, starting with moving over the 5 using subtraction, 0 minus 5 is negative 5. And then divide by 2, x is equal to negative 5 over 2 for one of our answers. Here, subtract 3 to isolate x, and 0 minus 3 is negative 3. In number 17, we're asked to solve using the quadratic formula. I went ahead and wrote down the quadratic formula for us here. We need to memorize this, where we need to know that a is 2, our first coefficient, then b, the second coefficient, is negative 6, and then the constant 3 is c that we are going to use in the formula. So x is equal to opposite b, or negative b means we take negative 6, change the sign, or do the opposite. Plus or minus the square root of b squared, so we have negative 6 squared, minus 4 times a times c. So again, I'm just plugging in these numbers. All of this divided by 2 times a. Underneath the radical, I'm going to show the work over here. We get negative 6 squared, which means negative 6 times negative 6, that's 36. Then right here, we have multiplication of 3 numbers. Negative 4 times 2 times 3. Negative 4 times 2 is negative 8, and negative 8 times 3 is negative 24. And then subtracting 36 and 24 gives us 12. So when I simplify everything in this square root, I end up with just the square root of 12. And we're dividing all of that by 2 times 2, that gives us 4. So for our class in geometry this year, it's okay to leave our answer like this. Next year in Algebra 2, we'll talk about how to simplify this and kind of what it means for a solution. Number 18 is more review from Unit 8, where we talk about the standard equation of the circle, which I wrote here, where HK is your center, which is given to us, and R is the radius. So based on the formula, since it says minus h and minus k, that means opposite of the numbers for h and k given. So we put in x minus 6 quantity squared plus y plus 8 quantity squared, right? So we're changing the signs of the numbers, plugging them in, and it's equal to the radius squared. So 2 squared would give us 4. For number 19, we have walls that are going to be painted. We want to paint 2 walls, it looks like. The walls are both 16 by 8, the window is 4 by 6, and the door is 7 by 3. We want to find the area that Jazzy wants to paint on the walls. So when we do this, we're going to figure out the total area of the walls, but there's 2 of them. So we're going to find that total area, but we don't want to paint the window and we don't want to paint the door. So from this, we're going to subtract the area of the window, and then we're going to go in and subtract also the area of the door, because those are not going to be painted. So we don't want to buy paint for that square space. So to find the area of 2 walls, we know that both of the walls are 8 by 16, right? So if I want to find the area of these, you would just multiply length times width. So the area here, 8 times 16. So the area of a rectangular wall would be length times width. So multiplying in the calculator, 16 times 8 gives us 128. But since there's 2 walls, I'm going to multiply this by 2. So the total space is 256. So I'm going to write that down here. 256. That's the 16 by 8 plus the 16 by 8. Okay, then we want to subtract the area of the window. So the window is very clearly a 4 by 6 rectangle. So to find the area of that, length times width, we get that the area is 24. We're going to be subtracting that from that 256. Then lastly, we have the door, 3 by 7, which we find the area by multiplying length and width because again, we have a rectangular door. So I'm going to be subtracting that 21 square feet. So in the calculator, when I subtract 24 from 256, I get 232, and then 232 minus 21 gives me 211. We have to paint, or she's going to need to paint 211 square feet. Each can contains enough paint to cover 50 feet. If she uses a single coat of paint, how many cans will she need to buy? Okay, so we're going to take the total area, divide it by the area of 1 can, and that'll tell us how many cans we need. So we have 211 divided by 50. That's 4.2 cans, but we need to make sure to buy enough, so we're going to round up. We need 5 cans. Okay, we have a cylindrical candle placed inside of a shipping box. We know the length of the candle, the box, we have all the dimensions. So what we're going to do first is find the volume of the rectangular prism. So we're multiplying the length and the width of the base times the height. So 16 times 16 times 20 gives us that the volume of the rectangular prism is 5,120 cubic inches. Then we're going to find the volume of the cylindrical candle. Using our formula for volume of a cylinder, we have very clearly that the radius of our cylinder is 5. The height of the candle is 20. So putting that into the calculator, pi times 5 squared times 20 is about 1,570, I'll round to say 0.8 cubic inches. So to find the volume of the airspace, that's the space left over inside of the container, we subtract the prism, the box that it's in. So we have 5,120 minus the space that the candle is taking up in there. So subtracting those will lead us to 3,549.2 cubic inches. So that would be the airspace left inside the container. Last question, we're asked to find the volume of the regular pyramid. I wrote down that formula for us. We could also use, since this is a square base, that's what the regular pyramid means. We have a square base. So we're going to find this as length times width times height divided by 3. But the first thing we need to see is that this is not the actual height that's given, that's the lateral height. So to find the lateral height, we will be using the Pythagorean theorem, where this is the hypotenuse, and this, oh, I almost made a mistake. That is not going to be the length on the bottom of the triangle. This is the length, because we know in the rectangular pyramid, the actual height is going to land right in the middle of the base. So this is 12 divided by 2. So then h squared plus 6 squared is equal to 18 squared. And we know 6 squared is 36. 18 squared is 324. So to solve for h, we have to subtract 36. And then our last step to get h is square rooting. So when we do the square root of 288, we're going to get an answer where you can round. But honestly, midway through the problem, you shouldn't round. We can leave our height as this. So now that I know the actual height, I'm ready to write in the volume is 12 times 12 for the area of the base, or you can think of as length and width. Then we're going to multiply by that actual height I found, which is the square root of 288, and since it's the volume of the pyramid, we don't want to forget to divide by 3. So putting all of this in my calculator using the 12 times 12 and then the square root of 288, I'm going to hit equals after multiplying the numerator and then divide by 3, and this gives us about 814.5, but I'll just round up to say 815 cubic inches, not inches, not sure what that is, but inches cubed. All right, good job, guys.